Okay, why don't we apply what we learned in the last segment to solve a particular question? Okay, here's what this question looks at. Y double prime plus 9y is equal to 0. And I was given that this is going to be sine 3x will be the solution to that. Actually, right there and then you can see that the second y2 will be cosine of 3x, right? Because if you plug that in, you'll see, you will cancel both of them, right? So, but let's find y2 is equal to cosine 3x. Now, let's go up here because we established the procedure and we will use this procedure to find it. So I will not be solving many questions from this segment because I derived you the equation. That is harder than putting a number and doing the integration and all. So I showed you how to do it. Let me ask you this. What is p of x? It is plus 9, correct? That would be wrong. I'll give you 2 seconds or 5 seconds to think about why it's wrong. Because, let me write it, because y double prime plus p of x y prime plus q of x y is equal to 0. Do you see something? This p of x is, there's no y prime, right? So then p of x is 0. You notice that, right? So be careful is where I'm going with this. I did it on purpose so that you can appreciate, in an exam stress what might happen to you, okay? All right, so I'm gonna apply this rule. So let me actually first deal with this, please, okay? Then I'll multiply by y1, okay? Because there's a lot going on. So let me take care of this first. So let's write it in here with another color. E to the minus integral of p of x dx, I'm just rewriting it, by y1 square of x dx. That's what I want to analyze. So let me rewrite this by inserting integral. So integral e minus 0 dx by y1 square x dx. What is the top? What is this? That's going to be a constant, right? The integral itself will be constant, the first integral that I'm evaluating. So that what it means is I will get myself e to the minus square 3x dx. I forgot the dx here. Okay. So I want to just give a, with different color, I want to highlight these things just to make sure that everybody's on the same page. Basically, so cosecant of an a will be 1 over sine a, okay? 2. Secant of a will be 1 over cosine of a, okay? And I also have cotangent. You can imagine, what it means. It's 1 over tangent, okay? So I will also write some integration formulas that you should know, okay? So this is something that I expect you to know. Cosecant square of x dx will be minus cotangent of x plus c. 1. 2. If I have a secant of x dx will be equal to tangent of x, again, plus the integration constant. So this, green font that I wrote, this is something that you're responsible from knowing. I'm not going to give these to you in the exam, okay? And as my exams are closed book, right? No formula sheet, no calculator. So you need to know these, okay? So looking at here, let me define here, right? So what I'm going to do is I'm going to just follow this rule. Here's what it says. If I have an integral, I can take k outside. Cosecant of 3x. So that, remember these things, right? So I'm going to write 1 over 3, right? Because I'm taking this, So I'm going to write this then. Let's go back here. Maybe we can write here. It will be better. So if I do that, what I will get here is I will get myself minus k by 3. Okay, minus is coming from the formula itself. Why I have 3? Because, hey, this is x, this is 3x. So it's going to be, the way that we take the derivatives and integrals, right? You know these rules. That's going to be the cotangent. What is cotangent? 1 over tangent, right? Of 3x plus c1. Right? Did we use C1? No, we didn't. We're good. So now I'm going to do something, and you'll see why in a minute. I'm going to say, and I did this in the derivation as well, I'll go ahead and say that this k over 3 is minus k over 3 is 1. And I will say C1 is equal to 0. So you may be saying, whoa, what is he doing? There's no initial condition, boundary condition. What's going on over here? Well, let me explain what's going on. I'm interested in the fundamental set. If I have, like C1 is equal to 17, Well, that's not really gonna help me. I'm interested in cosine. That's not gonna help me, right? So same thing over here, minus k by 3. So I'm gonna call this 1. Why? Because I want to get cotangent of 3x. Okay, we'll see in a minute why as well. And then I continue. Let's go to just another color, just for a change. Y2 of x will be equal to y1 of x, which is sine of 3x. That's one of the solutions, times the cotangent of 3x. And let's write it this way: sine 3x times cotangent is 1 over tangent, right? So I'm gonna write a sine of 3x over here, cosine of 3x over here, right? So you can see these two cancel, and surprise, surprise, I got myself what I kind of know already by starting this question. But just before you go, it's important. So this is the fundamental set, right? So where is it? Oh, here. I'm sorry, here. So then I'm not interested in the fundamental set. In a solution of a differential equation, I'm interested in general solution. The general solution then will be like this: c1 times sine 3x plus c2 of cosine of 3x. Okay, that's what I want you to box up, because this is what the solution is to this particular equation, the differential equation that's given to me. All right. So as I mentioned, let me talk about the limitations, because before I close off this segments where we talk about reduction of order, two limitations. One, I must know this, right? Did you see that? That's a problem. I must know this. Okay, if I don't know it, I cannot do the reduction. So I have to give you a solution, one of the solution, right? Second, it needs to be a second order, so I can reduce to the first order. As we mentioned, if it is fifth order, if you go down to fourth order, you're not going to be able to solve with the tactics that we establish. Okay, as long as those two conditions are satisfied, it's an excellent method. But how realistic is that? I'm going to leave that to you. Okay, have a great day. I will catch up with you in the next segment.